Hello and welcome back to another festive coding session with Mr. Jacob. On this 23rd day of the advent of languages, we are going to implement the same thing that we implemented now 22 times before in different languages in another different language, and we will implement it in fourth. And what are we going to implement? As always, we are implementing some sort of textual or ASCII representation of this Christmas tree, which is then configurable in size and renderable to a terminal. At least in most of the videos. We did this to a terminal. There were visual and graphical languages where we did this in a visual and graphical manner, but we want to do it to the terminal. Fourth actually is a little bit special and might look to you in the upcoming thing that we are going to do here, like an esoteric language, something like brainfuck or something like any other of those types of languages, which are not really used as a language, but just for fun and have just been invented for fun because it is possible. Fourth, on the other end, is a real language which can be used to actually implement real software in it. It is used to implement real software in it. You can, for example, talk to C libraries. You can bind this with C libraries. There are ways of interpreting forth. There are ways of JITting forth. There are ways of doing ahead of time compilation with forth and therefore creating real binaries for your system and all that kind of stuff. But it kind of looks at first like an esoteric language. That's why I'm saying that. Before we just dive into fourth, and I will explain to you what makes fourth a little bit special, I just have to tell you I have created a little sort of development environment kind of here. We are using an existing Docker image called GForce from 42, which actually has the so-called GForth interpreter in it, which is one of the interpreters which can be used to execute forth, and we can therefore run our fourth program with it. So and as you can see, there is nothing else here. So there's just this make file. So let's just dive right into it and get into our hello xmas.forth. And let's go in there. So what is so special about forth? First of all, let me tell you about its inline character symbols, which is you are simply using open and close parentheses, and then this is a comment. And I need to use those comments in a second to explain you what forth is, because forth is a completely stack-based programming language. So every operation that you do is always involving the stack. You are pushing data to the stack, you are popping data to the stack, you are duplicating data on the stack, you are kind of rotating data on the stack and stuff like that. You are always interacting with the stack. Every operation you do is based on the stack. So let's see what we can, for example, do. Let's say we want to add together the numbers 42 and 23. So we would kind of write it like that. And in the end, we would give it the word by. So all of those here operations are called words in forth. And this is the word by. So it's kind of an operation that we call out to the system to do. And what actually happens here, if we have a simple numeric value and we are actually executing that in forth, then it will simply push it to the stack. So this first operation here, if we have the stack here and it is empty, then the first operation will simply put the value 42 into the stack and point to this stack element here. This is the topmost stack element there. So the next operation then would simply remove this pointer, would put 23 on top here, and push that to the stack. Now we do a plus operation actually, and this plus operation would actually take two data entries from the stack, so the 23 and the 42, and we'll simply add those two up and push the result to the stack again. So now we should have the 65 on the stack if I have calculated correctly. If I have not, we will see that in a second, because there is another operation which actually consumes, it's the dot, it consumes the first thing here on the stack and prints it out to the screen as a number. So let's quickly see if this actually works like it should. So if we run this, we actually really get the number 65. And this is essentially how forth works. You have always this stack in the background, and it can be quite huge. And you can, with a couple of operations, you can actually manipulate this stack that you have here. So let's see, how can we actually do that? First of all, we need to be able to output text. And outputting text can actually be done with a special word, which is the dot start quotation here. So dot quotation mark is actually a specific kind of word which takes everything until it sees the next quotation mark and outputs that as text. And what is important is that there always needs to be a space here in between. So if I want to simply output hello world, I need to do it like that. Because otherwise, if I do it like that, Forth would have seen this whole thing as one word, and it actually can't process that. It needs this specific word here which tells it to output text now. That's the dot quotation mark thingy. And if I actually run this, you can see that it does not work because I just did a space there where it should not be. So now we have hello world. Okay, so we have a capability of outputting some sort of text. Forth is a lot more capable. You can have variables as well in certain situations. You can do a lot of different stuff. You can put pointers and stuff onto the stack, which then points in turn to memory addresses, which could contain strings and all of that stuff. You have a lot of things that you can do in Forth, and we will only use a little amount of that in our program. But let's for now just start and get going writing our Christmas tree out in Forth here. So what we first need is we need to be able to kind of define our own word, don't we? So what we want is we want to define our own word, which is tree in this case, which does something. And usually how you denote that, and this is a comment, so this is not code, but how you denote kind of function parameters that you give your word in this syntax directly after defining it. You are defining it with a colon here, then the name of the word, and then usually you provide what you will put in or what you would expect on the stack, because we will use the stack to pass arguments, what you would expect on the stack to be passed in a list, and then you do simply two minus signs, and then you provide what you will push onto the stack as a result. So we will consume groups from the stack, and we will push nothing as a result. But as I've said, this is only a comment. This is only for us humans reading that to know what we are doing there. And you end your own word with a semicolon, always. So what we are actually going to do here now is we need to print out some stuff. So we need to kind of print out our groups, as we always do. So let's maybe first of all get our quickly get our tree over here so that we can actually have that here as a reference, something like no, something like that maybe. Yes, perfect. And let's maybe get this. No, let's come on. Let's maybe get this over here a little, and this does not work, so let's do that manually quickly. Just like that. Okay, so now we kind of have our tree here. What we first need is we need to kind of print those groups here. So we need those groups to be printed out, which have a specific amount of spaces. Then we have a slash, then we have another amount of spaces, and then we have a backslash. And each of those groups actually consists of 2 lines. That's actually the first thing that our tree consists of, and we want to actually iterate over this amount of groups. So what we actually need to do here is we can use the do loop word, which we have actually in Forth. However, the do loop will loop from a specific amount inside the stack to a specific amount inside the stack, actually exclusive, so it will go to this limit -1, so to speak, and it will consume both of those variables, both of those stack values in the process. So what we need on the stack is we need on the stack as the second position on the stack, so the one below, we need the end to go to, and the first one should be the start. So we have already our end at the currently at the stack. So if we now push the 0 to the stack, that would actually be great. We would then have our starting point, the 0, and the end point, the groups. However, after that, groups is gone, and we might need it further down here for our divider, which we have here, or our trunk, which we have here. So what we first do is we duplicate our stack. And I can actually delimit all sorts of words and commands here by either space, tab, or new line. So it is always done in another way, just to make it more readable here. So I want to duplicate our stack. So now we have 2 times our groups value on the stack. Then I push the 0 onto the stack, and then I will do a do. And now I can actually do something until I have loop. And everything I have in here will actually be called this amount of times. And during this iteration time, we have a specific variable within our iteration body, which is called I, which is automatically the counter there that we can actually access. So what are we doing within our groups? Yeah, maybe we could call the grouping here, or the group drawing function better said, like we could call group here. And how would we call group actually? Group would need, and we create that quickly, group would need something like, and we know that already, the amount of groups that we actually have to be drawing, as well as the current iteration, which we call n usually, and we will not return anything on the stack. So we need these 2 values on the stack. And we actually already have, because we duplicated it before. That was kind of intelligent from us. We duplicated the groups, so they are already on the stack. So what we need further down here is we need the current iteration. So we simply push I to the stack, and then we call group. And this should actually work. However, we will consume the group. So what we first need to do is we need to duplicate again what is on the currently on the stack, which is groups. And then we will push the I, and then we will call groups, so that we can then actually consume that here. And now we have our word called groups here, and groups will actually now need to print actually out those spaces here, doesn't it? And the spaces amount that it actually needs to print here is always the full amount of groups minus the current grouping level. So if it's actually the zeros grouping level, it will be groups minus 0. So I guess we need to first calculate that value, don't we? So what we actually can do here is now, and we will need that both of those values, we will need those anyways. But so what we can do is here we duplicate actually 2 values. So there is actually 2 dub, which actually duplicates the 2 most values on the 2 uppermost values on the stack. So if we do 2 dub, we have now duplicated groups and n. And after we have done that, we can actually just call a minus, and we will then calculate the groups minus the n. And that's exactly what we want. And now we have that on the stack, and we have those groups and n before that, so to use it later on. So we now have the amount of spaces that we need to print. And there is this neat word which exists actually in Forth, which is spaces. And if you call spaces, it will consume the topmost entry of the stack and will simply print out that many spaces on the screen. So it's perfectly what we need. After that, we simply want to do a slash. And after we have done that slash, we want to actually have this inner amount of spaces here. And this inner amount of spaces actually is the n times 2. So we need to duplicate the uppermost entry, which is still the n, because we duplicated it before here. We duplicate the n, then we take that, we push a 2, and then we multiply. So we simply say to the system, okay, to take the uppermost entries, which is now the n and the 2, and multiply them together and push that result back to the stack. So now we actually have the amount of spaces on the stack that we need there. So we can actually call spaces again, and spaces will draw out those spaces. And we have now the opportunity to actually, or we need to print out the backslash here, which we are doing like that, the same way as with the slash. And then we need a carriage return at the end, because we want a new line there. So, and we can simply do that with the carriage return, the CR word, which is a special word there as well. I could have put that in the next line, but I like it more like that. I don't know why. It's not, it doesn't matter, because the words are separated by new lines, by tabs, or by spaces. It's doing all the same things here. So now we have one line actually of this group. So now we need the second line of this group. And the second line of this group is actually something different, because the first space iteration here, what we need here is one space less. So we need to kind of just not do this minus directly, but we need to we need to separate the n from the groups. That's correct. Then we will push a 1 to the stack, and then we'll separate this one from the result value as well, and then we will do print spaces, then a slash, and now we need n plus 1 times 2 spaces. So actually, before pushing this 2 to the stack, what we will do is we will simply push a 1 to the stack and call a plus. So we will now take the n value, then we plus it with 1, then we push the 2 value, and then we multiply that whole thing, and then we will print that many spaces, and then a backslash again, and a new line. And if I now actually have this one here and I call our tree here, it will not work, because we've forgotten something. We have forgotten that our tree actually needs the groups on the stack, because it is consuming that, or it's using that for iteration. So if I do something like I push 5 on the stack and then call tree, let's see what actually happens here. And it seems that I did something wrong there. Okay, undefined word group. So yeah. Actually, the order in which we define things is important in Forth. So if we are using a group somewhere, like for example, a word here, like for example, we use the group word here, we need to define it beforehand. So I just reordered that, and now maybe it should work. Okay, it kind of works. We did something wrong there with the indentation at the beginning. So let's see what we did wrong there. So something's wrong with this. So let's maybe quickly take a look at the stack at this position here. So what we can do actually is, using .s, we can simply print out the stack. So let's see what we did wrong there. We actually start on the stack with a 5, 5, 0. That's actually perfectly right. And then we kind of have 5, 5, 0, 0, 1, and this stack is always getting bigger. And I think I just did not consume everything at the end of our tree, did I? So what I did do here is I kind of duplicated the n here again. However, I should maybe not have duplicated that n here, because I want to use that up. The problem is that we are letting when we are doing each of those group iterations, we have still this groups and n on the stack, because we are always duplicating and then using it. So maybe we don't need to do that. The last thing where we do this here is actually duplicating the n. However, we don't need the groups as well. So we could maybe make this one a dup and remove this dup. However, I think that this is kind of maybe not the best thing to do. So we can actually simply drop those two values at the end, because I think that is a little bit more readable in the end. So now, as you can see, even though we printed out our stack, we have a correctly formatted Christmas tree. Perfect. So what we now need is we need not only the groups printed out, but we need the divider as well. And we, of course, need the groups amount there, of course, as well. So we duplicate the groups, because our divider, which we will be writing in a second here, will consume those groups. So what we are doing here is we are consuming that, and we are putting nothing back at the stack. So what our divider actually needs to do is it needs to print spaces, and it needs to print spaces the amount of groups times 2 plus 2. So what we are actually just doing here is we are consuming groups, and we are pushing 2 here, multiplying it with that, pushing 2 again, and adding that. So we have groups times 2 plus 2. And actually we have this result then at the stack, and can do spaces here just to print out that corresponding amount of spaces. And as we did not duplicate the amount here, we have actually consumed that groups here in the end, and this should then actually print our spaces. It does not, because we need to print out a new line at the end. Maybe that's why did I do I'm sorry, why did I do spaces? I didn't want to do spaces. I needed the minus characters there. So what we actually need to do is, now we have this at the stack. We actually need our starting point here at the stack, and then we do a loop here, which is then simply maybe outputting, yeah, I guess a minus character, and then no, sorry, a do here, not a loop. We do a do here, come on, where we print this minus character actually, and then we do a loop here, and this should then actually, and after that we will do a carriage return, and yeah, this is actually printing out our divider nicely. So what we need now is we need our trunk. So what we can do here is we can now print out our trunk, and I'm not duplicating the value anymore because we will not use the groups after that anymore because we are finished, so we can actually consume that. So let's define our trunk here, which is actually our group, which is minus minus. It takes the groups there, it will consume that, and it will not output anything back to the stack there. And the groups actually now need spacing, and they need exactly the amount of groups spacing, which is kind of perfect. However, we still duplicate that because we need those two lines after each other, and for each line we need the spaces count. So let's first duplicate that, then we print that amount of spaces, then we simply print out this pipe characters there. Then we will print then we will do a new line, then we will print spaces again, and by that consuming the groups from the stack. And then we will, in the end, print those thingies here again, and a new line at the end. And if I now do that, it should actually print a proper Christmas tree. And as you can see, if I push another value to the tree here, for example 10, I push something else to the stack here, and then I execute that, I get a much bigger Christmas tree. So it is actually using this stack to transfer data from A to B. And yeah, that is a very minimal demonstration of Forth, what I've just given you here, because that is actually kind of how Forth works. But as I've said, Forth have a lot more included words here which we could use. We have primarily only used mathematical expressions like plus and multiplied and so on, and we have simply duplicated things on the stack and outputted some strings there. There are operations which can do logical expressions and comparisons. There is, as I've said, possibilities to have strings in memory and reference them by pointers and all that kind of stuff. And you can really program large programs in Forth. It is possible, and it is done actually. I know, for example, there are microcontrollers or microcontroller software that I know of that is written in Forth. So it is done. Because it can actually be very efficiently compiled to machine code, because you are essentially doing nothing that is not a real machine code operation there. So it is quite good to go. I hope you had fun on this 23rd day of December in our Advent of Languages, the last one before our big finale tomorrow at Christmas at the 24th. And I hope you will be there and you will be looking at that. And I hope you looked at the ones before and had fun and gave them a thumbs up. And please leave me a comment if you like something like that, or not, if you did not. But please comment the videos, because that actually really helps with the YouTube algorithm as well. I hope you might have enjoyed this and learned something about Forth, and maybe didn't even know that something like this existed before. So I hope to see you in the big finale tomorrow. Thank you and goodbye.